Hello everyone, in today's video we're diving into inverse matrices. They play a crucial role in solving systems of equations and other advanced matrix operations. Let's solve an example to understand the process. For those new to matrices, a refresher video is linked in the description. Feel free to leave a comment suggesting a future topic, and if you find this helpful, hit that like and subscribe button to support me. Let's get started. There is many ways that we can use to find the inverse matrix, but for me, this is the easiest. So inverse of matrix A equal adjoint over determinant of matrix A, which is equal the transpose of the cofactor over the determinant. But to calculate the inverse, we have two conditions. First, it should be a square matrix, which means it should contain same number of rows and columns. And second, the determinant of the matrix should not be equal 0. Now let's take this example and apply the rule. So first we should check the determinant condition. And in this example, it is equal 46. If you don't know how to calculate it, there is a video link in the description about determinant. Since determinant not equal to 0 and it is a square matrix, then we can use the formula to calculate the inverse. So let's start by the cofactor. We start by the first row and column, and we take the rest, then just a simple calculation to get the first element equal minus 14. Same for the first row and second column, and the answer is 12. So do the same for the rest to get the following matrix. Next step is to transpose the matrix, so we just flips its rows and columns, creating a mirror image. And the answer should be like this. The final step is to divide each element by the determinant to get the final answer as follows.